In this video now we try to learn about the Carnot cycle. It is a theoretical process. It is designed to obtain maximum work from the heat engine. Carnot heat engine contains 1 mole ideal gas and works between source and source is maintained at the temperature T2 and the sink is kept at the temperature T1. Cycle contains 4 different steps in it. First step is the isothermal reversible expansion. Second step is the adiabatic reversible expansion. Step is the isothermal reversible contraction, and fourth step is the adiabatic reversible contraction. We know very well that the work done by the heat engine can be calculated by using the PV graph. Here it is the P versus V graph for the Carnot cycle. First step of the Carnot cycle is the isothermal reversible expansion, and in this case the work is done by the system, so work gets the negative symbol, so W becomes minus W1, and in this one the system absorbs the heat. So here the Q amount of heat is supplied to the system, and in the isothermal process the change in the internal is 0. So the work done by the system becomes equal to the minus W1 is equal to the Q2 is equal to RT2 ln V2 by V1. The second step in the Carnot cycle is the adiabatic reversible expansion. Here also the work is done by the system, so work gets the negative symbol, so W becomes minus W2, and here as the system does not absorb the heat, the dq becomes 0, and here the system does the work at the cost of the internal energy, so the internal energy gets a negative symbol. So here the equation for the internal energy is equal to the minus CV T2 minus T1. So the equation for the work done by the system in this stage it becomes minus W2 is equal to delta E is equal to the minus CV T2 minus T1. Third step in the Carnot cycle is the isothermal reversible contraction. Here as the work is done on the system, W work gets the positive symbol, so W becomes plus W3, and the amount of here the amount of heat releases by the system, so here it is becomes equal to the dq is equal to minus q1, and in the isothermal process internal energy change is 0, so dE or delta E is equal to 0. So in this step the work done on the system can be calculated by the equation plus W3 is equal to the minus q1 is equal to RT1 ln V4 by V3. And fourth stage in the Carnot cycle is the adiabatic reversible contraction. Here also the work is done on the system, so work gets the positive symbol, so W becomes equal to the plus W4, and as the heat is not exchanged with the surroundings, the dq becomes equal to the 0, and as the contraction takes place the internal energy of the system increases, so the internal energy gets the positive symbol. The work done on the system in this process can be calculated by the equation plus W4 is equal to the dE is equal to the CV T2 minus T1. If we club all these 4 equations used for the work calculation, we get the net work done by the system, and the net work done by the system becomes equal to the RT2 ln V2 by V1 plus RT1 ln V4 by V3. We can consider this as the equation 1. Stage 2 and stage 4 are adiabatic paths. So if we apply the T into V to the power of gamma minus 1 equation to the B, C and AD systems, then we get T2 into V2 to the power of gamma minus 1 is equal to the T1 V3 to the power of gamma minus 1, or T2 by T1 is equal to V3 by V2 to the power all to the power of gamma minus 1. We can consider this as the equation 2. The fourth stage we get T2 into V to the power of gamma minus 1 is equal to the T1 into V4 to the power of gamma minus 1, or this becomes as the T2 by T1 is equal to the V4 by V3 all to the power of gamma minus 1. We can consider this as the equation 3. The equation 2 and 3 are same, we can make them equal. By making them equal, we get V3 by V4 is equal to the V2 by V1. We can consider this as the equation 4. By substituting equation 4 in the equation 1, we get the final equation for the calculation of the network done. That is R into T2 minus T1 by ln V2 by V1. And the amount of heat absorbed by the system is equal to the Q2. Q2 is nothing but equal to the RT2 ln V2 by V1. So the equation to calculate the efficiency of heat engine can be expressed as the net work done by the system upon the amount of the heat absorbed. So on writing these two equations, we get the final equation to calculate the efficiency of the heat engine, that is equal to the neta is equal to the T2 minus T1 by T2. Here the efficiency of the heat engine depends only on the initial and final temperatures in between which this system will be operated.